Okay, I'm going to go over the dot product of two vectors here. So just to let you know, the dot product is defined if you have vector u with components u1, u2, and v with v1, v2, then the dot product, and we talk about this as it's a dot. It is not multiplication per se. You don't use an X, you use the dot, okay? And it is u1 times v1 plus u2 times v2, okay? And your answer turns out to be, your answer is, I'll say, your answer is a scalar constant, okay? You get an actual number as your answer, okay? And I'm going to go over some properties here, okay? And in these, you're going to assume u, v, and w are vectors, and c is a scalar constant. So you've got what amounts to the commutative property. U dot v is the same as v dot u, okay? If you multiply a vector times 0, the dot product of 0 and a vector is 0. I keep going. U dot v plus w is u dot v plus u dot w. Think distributive property there. If you take the dot product of the same vector twice, it's almost like you're squaring it, so you're getting the magnitude squared. And then the last one, if you take a scalar and multiply it by your dot product, it's as if you're multiplying one piece by the scalar, c times u dot v, or u times c dot v. All right, you think about that in multiplication. If you had 4 times 3 times 2, you would either do 4 times 3 times 2 or 4 times 3 times 2. You wouldn't do 4 times 3 times 4 times 2. Same concept, okay? Let's got a couple examples here for you. 1, 4 comma 5 dot 2, 3. So you have 4 times 2 plus 5 times 3. 4 times 2 is 8. 5 times 3 is 15. You add them up. 23 is your dot product. Okay, now I'm going to have another one that's a little more extensive. You know, I've got 3 vectors, u, v, and w, and I want the dot product of u times v times w. So first we're going to do u dot v, and then we're going to, that's going to be negative 1 times 2, negative 1 and 2, plus 3 times negative 4. So we get negative 2 plus negative 12, that's negative 14. Now we're going to take negative 14 times 1 comma negative 2, and it's negative 14 comma 28 is your final answer. Okay, that's one piece of it. I'm going to keep going on here. Another thing you can do with dot products is you can find the angle between two vectors. Okay, the angle between two vectors, theta, when 0 is less than or equal to theta, which is less than or equal to 180 degrees, is cosine of theta is u dot v over the magnitude of u times the magnitude of v. Okay, it's just a straightforward formula, and I'm going to use it here. Find the angle between vectors 4, 3 and 3, 4. Okay, so we know that the cosine of theta is u dot v over the magnitude of u times the magnitude of v. Okay, I'm going to do this in 3 parts. I'm going to do u dot v first, and that's going to give me 4 times 3 plus 3 times 5, and that's 27. Okay, now I'm going to find the magnitude of u, and if you remember that, it is each component squared under the square root, adding them under the square root. So it's 4 squared plus 3 squared. Okay, and that's radical 16 plus 9, which is radical 25, and we all know the square root of 25 is 5. Okay, and now I'm going to do the same thing for v. And it's going to be 3 squared plus 5 squared. The square root of 9 plus 25 is the square root of 34. And we are not going to simplify that. We can't simplify that radical. So when we put it all together, we get the cosine of theta is 27 over 5 radical 34. Now into our calculators, we're going to do theta is arc cosine 27 over 5 radical 34. And another way to put that in the calculator, cosine inverse 27 over 5 radical 34, and theta ends up being, when you put that into the calculator, 22.2 degrees. Okay, there's that example. One last piece here I want to give you. When vectors u and v are orthogonal, if the dot product is 0. Orthogonal is another word for saying perpendicular. We talk about lines that are perpendicular. When we're talking about vectors, we use the phrase orthogonal. Okay? I hope that's good for everybody. I'm going to be posting the second part of these notes right after this. They'll be together. It's just a separate video, so you can take your time watching them. Okay? Hope everything's going well. Stay safe, stay healthy.